say I saw myself as an advocate for U.S. manufacturing. That was definitely nothing I thought about when I was in college. My career started in the aerospace industry, and had a great time. I thought that's what I would do for a long time, but after several years, there was an opportunity to move back to the Midwest. Took a job at Ford Motor Company and ended up working in their vehicle safety group, working in their basically crashing cars. After a few years of that, I ended up moving to a small automotive supplier where I spent a big part of my career, that I really had that opportunity, and to where you're not just designing parts and testing parts, you're actually working with the line. You're going out on the factory floor talking to not just line supervisors, but the guys actually running the line, the girls doing the assembly, and understanding how to do things better, from their standpoint. There, I really gained an appreciation for what manufacturing is. And now being at NCMS, it's really exciting to be really working with just manufacturing from all sectors all over the country. And you just see the passion of these companies, these owners, these people that are making products, making stuff. And it's really the heartbeat of who the United States is, and it's exciting. We talked for a long time about, the M word, manufacturing, and different people have different views of manufacturing. I think the layperson, thinks of manufacturing, they think of turning nuts on bolts, they think of greasy environments, they think of the smokestacks. We need to change that paradigm. Most modern manufacturers are highly digital, clean, eat off the floor, and skilled workforce. But that reality of what manufacturing is hasn't been translated into the awareness of the public opinion. But we need to help, I think, bring to light what manufacturing is today. We're not in Henry Ford's plant anymore. We're not making Model Ts. We're making tiles for the space shuttle. We're working on exotic materials, and it's we need to convey that. We need to do a better job of making that reality. When people talk manufacturing, they do think the big boys, and it's here in Michigan, it's Ford, Chrysler, GM, it's maybe a few other companies, but that's what they think of. America is filled with 300,000 of these little companies you drive by every day that make our economy hum. That's where most people work. 2 out of 3 manufacturing jobs are there, and they're highly skilled, highly competent, highly innovative people, and we need to get the word out that this is the engine behind manufacturing, is these small and medium-sized guys. Hi, my name is Jon Riley, and I'm the Executive Director of Design Engineering Programs at the National Center for Manufacturing Sciences, and I'm here today to talk to you really about 2 things. One is something we call the missing middle, and they're an enormous pool of small, medium-sized manufacturers located in every country in the world. The second thing we want to talk about is a transformative process of getting these companies the innovative and the technology tools they so desperately need to be competitive. You like astronomy? I did. Space is cool. I mean, you see the pictures of the Hubble telescope. That's some pretty wild stuff. But you know what? Space is also kind of weird. There was this guy back in the 30s. His name was Fritz Zwicky. Fritz Zwicky came up with this idea where he could look at clusters. What a cluster is you look at space and you see the stars, and the stars form galaxies. You put a bunch of galaxies together, it's called a cluster. And he figured out a way that you could look at a cluster in space and you could measure the mass of the entire cluster. The problem is the mass of the cluster of stars and galaxies did not add up to the individual mass of the stars and the galaxies. It was actually an enormous difference. And so what do most scientists do? They make up something to balance the books, right? So they come up with this idea called dark matter. And dark matter is basically everything they can't see, but they know must be there because their mass calculations don't connect. There was this dark matter that was filling in all the space. You couldn't see it, it was invisible, but it made up a majority of the mass in outer space. And so there's an analogy here between dark matter and the missing middle. The dark matter of manufacturing is the missing middle. And so if you look at manufacturing, you have this enormous volume of manufacturers that people just don't see. They're almost invisible. You drive by them every day, they're there, they're the heartbeat of manufacturing, but they're almost invisible. The dark matter of manufacturing. and they are the neck that turns the head of industry. All the Boeings, the GEs, the Lockheeds, the Procter & Gambles, all the automakers, every large company that you heard of depend on the missing middle for their operations and arguably their existence. The missing middle is a foundation of production, process, design, and innovation across every manufacturing sector around the world. Now, some of you are going to say, John, you got that backwards. The missing middle only exists because of the Fords and the Procter & Gambles of the world. And 30 years ago, I would have agreed with you, but not anymore. Economically, it is responsible for more than twice as much employment as all the big manufacturers combined. Developmentally, the past 30 years, R&D investments in the larger companies have plummeted from 72% back in 81 to 40% in 2007. But innovation can't stop. So what are the larger organizations doing? The ones that once dominated R&D are now pushing their innovation demands down onto the missing middle itself. The smallest enterprises now shoulder the burden of innovation. The missing middle is functionally capable of driving R&D. I mean, after all, it's been doing it for years, but it lacks the infrastructure, the investment, and the talent to really maximize the opportunity. All of these things can be realized by applying the right collaborative processes. Organizations that collaborate effectively are more competitive, which is a good place to introduce NCMS. The National Center for Manufacturing Sciences was established by executive order back in 1986. Its purpose, well, is to enhance the competitiveness of U.S. manufacturers by providing an impartial, collaborative R&D management environment. Since that time, we've grown and expanded our mission and services beyond simple R&D management. We provide tools, training, technology, processes, advocacy for all manufacturers of all sizes. In the time since we got started, we've leveraged billions in research funds. We have won more than 24 national and international innovation awards, and we have helped our members grow and compete. But one thing remains unchanged, is our commitment to collaboration. NCMS has a fairly straightforward model. Collaborate, innovate, commercialize. It's what we do. We champion collaboration. Collaboration is bringing together parties that can share the load. We share the risk, we share the cost, and in the end, you basically then reduce the risk. You reduce the overall cost. You reduce the time to market. And we do this in order to drive innovations to commercialization. I mean, innovations are great. You can come up with all kinds of great ideas, you can patent things, and they can be really cool ideas for the next widget, but if you don't commercialize them, they're just a piece of paper. They don't go anywhere. They don't really add to the viability of a company. Collaboration brings together three key drivers: talent, investment, and infrastructure. A lot of companies have one, maybe two of these, but very few companies have all three. Without them, your cost goes up, your risk goes up, and it takes longer to get to market. And so NCMS basically surrounds companies that come in to collaborate with us with other companies, other organizations that have the talent, have the investment, have the infrastructure, so that we can innovate with all three drivers. But it doesn't stop there, because I said we've got to commercialize these innovations. And so that's when we finish the table of collaboration by bringing the other side. They're technology integrators, technology developers, and the very all-important end user. So what are we talking about here by technology developer and technology integrator? A home PC is probably as the best of example as I can think of. Most of us have a home computer. It's by HP or Dell or wherever you get it, Lenovo. Inside of that computer is the brains that make it work. It's the chips. Come from AMD or Intel typically. So let's say Intel is a technology developer. They develop the chips. HP is a technology integrator. They take the chips and they put it into a product that we buy. The end user is us. We're the customer. And so imagine taking a missing middle company, a small manufacturer that has a cool idea. They might be the technology developer. They might have the greatest widget. Or maybe they have processes to integrate cool ideas and they're a technology developer. Maybe they're the customer looking for technologies to do all of those things. They're sitting at the table. They're surrounded by very talented people, universities, national labs, other manufacturers, large, small. They're surrounded by people that have funding, private or government. The infrastructure is in place. And then you have these other players sitting there. Now you have a collaborative model that can take all of those resources, all of the drivers for innovation, and commercialize solutions. And in this case, we're talking about technologies for the missing middle to enable them to leverage the latent innovation that's within them. You start putting these tools into the hands of companies, they become more efficient, more cost competitive, and just more prosperous. Everything is collaborative. So I mean, we want people to think collaboratively. We believe it reduces cost, reduces risk, gets things done faster, gets you to market faster. If we can figure out how to translate that from a business standpoint into these small, medium-sized manufacturers, the potential is just unbelievable. So who are these companies that NCMS works with? I mean, we have a lot of members. We have 400 active members, but we work with thousands of companies. About 2/3 of those we would call missing middle. And many of those we would classify as innovative companies. And so what makes an innovative company? There's really four pieces of that. Obviously, we've been talking about this collaborative interest. They have the desire to collaborate, sustainable innovation. They're looking for how to continue to grow and develop innovation. They're also nimble. They are willing to take some calculated risks. They're not stuck in a box. They have some flexibility about them. There's this human potential. And I talk about this 360-degree empowerment of the human element of a company. And by that I mean internally you have people. I don't care what your title is. I don't care what your job description is. You have a voice. And the innovative companies leverage those voices. You are able to talk with your peers, you're able to talk to your manager, you're able to talk to the people that report to you, and you're able to take those voices and leverage the wealth of information and capabilities that those individuals have. And it's not just internal to the company, it's also external. How do you leverage the human voice of your customers, of your supply chain? Innovative companies have figured out how to do that, and they leverage it to their benefit. And the last piece here is this critical idea of self-evaluation. They can take a look at themselves honestly and say, how do we get better? Where are we doing wrong? Where do we have room for improvement? And through talking to their people and their nimble ability to adapt, they can change, they can evolve, they can become better at what they do. Those are innovative companies. We view the missing middle as tomorrow manufacturing. Now at NCMS, we have a real honor of working with a lot of small and medium-sized manufacturers. We have been able to work with them and begin to understand where the problems are, the barriers to getting these tools, what kind of tools are necessary, and we've started looking at a lot of the tools that are out there. And I'm going to tell you, there's a lot of cool stuff that have been developed by a lot of very powerful companies that are all very effective at helping small, medium-sized manufacturers. But there is one that has kind of risen to the surface that has been what we call a differentiator, and that's digital manufacturing tools. And we see that as a 21st century game changer, and that's what I want to talk about for a moment. I'm standing here in downtown Detroit, Motown, the home of the auto industry. 100 years ago, the auto industry really took off when Henry Ford took the assembly line and created mass production. What was once an oddity in a car became the Model T, which is now 2 cars in every garage. Mass production drove low-cost consumer products. It made viable so many technologies to the mass public. It was a true transformational game changer for manufacturing. But that was 100 years ago. Digital manufacturing tools we view as a transformational tool, a game changer for the 21st century.
There's a lot of interesting and cool technologies that are being developed and integrated, but they're mostly in pockets, and they're not really being broadly adopted, not like the assembly line. And so one of the things at NCMS is we're trying to introduce what we believe to be a key component, if not the component, of the 21st century game changer, and that's this idea of digital manufacturing, smart manufacturing tools, using data. All the data that comes off of the equipment on the factory floor, all the data that's being developed by design engineers, all the data in the business systems. You know, there's ERP and there's CAD and there's modeling and simulation, but all of those things need to be tied together. And we believe that digital manufacturing is the way to do that.
So what is digital manufacturing? I mean, it goes by a lot of names, some better, some worse. I mean, some people have called it high-performance computing. I don't really like that one. Some people call it modeling and simulation. That's pretty good. But digital manufacturing is leveraging data to get your job done smarter, faster, better. And so digital manufacturing, a lot of people, they hear that and they think CAD. It's not CAD. What is CAD? CAD is a great tool, computer-aided design. It basically sets someone in a tube and they can draw a part and they can work on the geometry, they can get it precise, and they can show this is what the thing looks like. It does not tell you how it's made. It does not tell you what material it is. It doesn't tell you, is this radius the optimal radius? Is my design the best for how we're going to manufacture it? It does none of those things. What digital manufacturing does is it allows me to look at all possible materials, all possible design parameters, different types of processes. How could I manufacture this different? What's my design for manufacturing parameters that could drive cost into this design? Digital manufacturing takes all of that stuff and wraps it into something before you design a part that becomes truly optimal. That's digital manufacturing. And so when we talk about digital manufacturing tools being transformational, it is an order of magnitude beyond CAD. It's the tools before CAD. The other aspect that differentiates digital manufacturing is its ability to look at conflicting requirements. Well, what on earth is a conflicting requirement? A conflicting requirement is when I want a car to be safer but lighter. I want it to basically hold the road better, which means more friction between my tires and the road, but I want to get better gas mileage. Those conflict. Those requirements don't go together. You know, lighter and more fuel efficient go together. Lighter and safer do not. Digital manufacturing, I could literally take a look at parameters that would affect how do I make it lighter, how do I make it safer, and find where those connect. For instance, Roof Crush wants the roofs to be stronger so when the car rolls over, people don't get injured. Usually what that means is adding more steel, beefing up the sections of what's called the pillars that come up the car to make the roof stronger. Problem with that is it usually cuts down my line of sight. It makes the car heavier, and so the car doesn't get the fuel mileage you want. What happens if I took digital manufacturing tools to virtually evaluate different design methodologies, different cross sections of pillars, different materials, different manufacturing processes that not only made the roof stronger, but in the process made the car lighter? Maybe make it more aerodynamic, improving fuel mileage. Digital manufacturing can do those things. Digital manufacturing is really a two-pronged approach. It's an IT-enabled manufacturing technology that includes modeling and simulation, and includes smart manufacturing. Modeling and simulation we've been talking about a little bit, but we're talking about the idea to broadly make accessible, affordable, and scalable technologies that allow you to virtually look at design decisions before you make your design. And so we talked about hitting a button, making a roof 20% lighter. How do I make this bottle lighter? We're going to give you a couple of examples in a minute. Smart manufacturing, what we're talking about there is we're talking about real-time data interoperability. We're talking about tying the shop floor to the product development center to the business office and having those things talk to each other so that real-time decision can be done. So it's basically elevating digital manufacturing tools with just the modeling and simulation components up to making smart decisions on a real-time basis. Let me give you two real-world examples of the power of digital manufacturing. One is from Alcoa. I think all of us have heard of Alcoa. It's synonymous with aluminum. Aluminum cans we see every day. The common way to make aluminum cans was I would design with CAD, I would prototype, make a part, I would test it, it wouldn't work, I would redesign it, I would make another prototype, I would test it again, hope it worked, probably wouldn't, go through this until I had a functional design. Nowhere in here am I saying optimal. I'm saying functional. It met the spec. It met what the can was supposed to do. It does not mean it was optimal. It also meant that I went through a lot of loops, and for anybody that's done this, making prototypes doesn't happen overnight. It sometimes can take weeks, even months, to make a single prototype, to do the test to find out it didn't work. A long time, a lot of cost. Alcoa virtualized the entire process. Let's virtually design the can. Let's virtually make a prototype. Let's virtually test it. And then find out what didn't work and go through and do this all again, but they're doing it real time because they can say, I want a can that does this, and oh, by the way, I want to get some of the weight out. And the computers go off and they digitally manufacture that component, and at the end, they can validate it with a single test. The results, 98% reduction in prototyping costs because they stopped prototyping. They have one test. They validate at the end. That's it. 98% reduction. Alcoa can do this because they have the talent, investment, and the infrastructure. Why can't every company do this? Another example is Ping. For those of you who golf, everybody's heard of Ping. What most of us don't realize is that Ping is not a very big manufacturing company. But what they are is they're innovative and they're proactive. And as a company, they decided to invest on their own in some digital manufacturing tools. Not a lot, but enough. And they went ahead and they incorporated that into their design process. And in the end, were able to reduce their time to market with their nice golf clubs by 66%. Now, I don't know if that means anything to you. It means a lot to business people in manufacturing. A 66% reduction in time to market is a game changer. I worked in the auto industry for several years. Our goal was always 2 years for the next model to come out. Often it would take 36 months, maybe even 48. Nobody was happy. Got to get to 2 years. Imagine if they could go from 36 to 12. Every car company in the world would drool over that kind of time to market, and that's exactly what Ping did. But if you look at the numbers, and this is a survey that NCMS did last year among the missing middle, 84% of missing middle companies have nothing. They have no digital manufacturing capability. They may have 3D CAD, but remember, that's not digital manufacturing. They have no ability to virtual prototype, virtually develop. They have nothing. Only 4% would be what we would call advanced, and that's where Ping would sit. We need to figure out how to bridge these technologies to these companies. Now, in Ping's case, they were able to do it alone. But I'm going to tell you, there was a lot of risk involved. There was added cost that may not have needed to be involved if they had collaborated. They went for it. It worked for them. I'm thrilled. For most companies, they're not going to take that step because of the perceived cost, the risk, or how long it's going to take. So the missing middle, 84% of them at least, don't have any digital manufacturing capabilities. The first question we obviously ask ourselves is why? And we come back to those same three words I keep saying over and over again: talent, investment, infrastructure. Many of the missing middle have one, some have two, very, very few have all three. So we need to figure out how do we bridge the gap to get the rest of the innovation drivers that are missing at the missing middle incorporated. Collaboration. So at NCMS, we are implementing our collaborative model, this idea of collaborate, innovate, commercialize, in centers that we're calling predictive innovation centers, or PICs. The strategy here is to set up about a dozen of these centers around the country. We are going to be working with federal and private funding. We're working with universities, national labs, large manufacturers, small manufacturers, providers, vendors, you name it. All the different skill set that be around that collaborative table are coming together to form these collaborative PICs. Now, at a PIC, we want to engage the missing middle. Now, how do we do that? Missing middle are going to come at all different sizes and shapes, and they're going to come at all different levels of maybe understanding of digital manufacturing. And so we need to be prepared to meet them where they're at. And so we've created a four-rung ladder approach to engagement. The first rung in the ladder is education. A lot of these companies don't understand the value of these tools. We need to create an awareness for these companies and begin to show them what the value is for them. How can they incorporate these tools? The second rung of the ladder is entice. And this is going to be a place where companies can come in at no cost or at low cost and come in and play with modeling and simulation tools. They can begin to experience what these tools do, be able to partner with people that have the talent, have the resources, have the infrastructure to gain exposure into the power of digital manufacturing. And through that, they're going to have an aha moment. They're going to say, oh, could it do this? Could it solve this problem? And the answer is almost always yes. And so then they say, okay, how do I do that? Then they move to the third rung, engagement. Now we're engaging them in real problem solving, collaboratively leveraging the other talent, investment, and infrastructure within the PIC to start solving their problems. Then when they've engaged, they're going to say, okay, I see the benefit, I'm using it, how do I incorporate this into my process? It could be daily, weekly, monthly, whatever that is. They're going to begin to elevate their capabilities by using these on a regular basis. And for each company, it could be different. For some companies, it's going to be, we want to buy this. We want to purchase some level of capability, like Ping. Now, it took them 3 rungs to get to where Ping's at, and they were able to do it collaboratively, so the cost and the risk was next to nothing. But now they can go ahead and invest. Or maybe they say, you know what, we're not going to invest. We don't think we need it that much, but now we have all these resources we have access to. Remember, I said at the very beginning, affordable, accessible, scalable. The PICs offer that. So NCMS is already actively moving on this. We're building awareness, and one of the key avenues we're going to be doing that is with a new partnership we have with Tabor Communications. Many people associated with modeling and simulation and computing know Tabor very well. They're very well known for their two websites, HPC Wire, HPC in the Cloud. NCMS has partnered with Tabor Communication to create a third website called Digital Manufacturing Report. The sole focus of this website is the missing middle. It's about creating awareness of the value of the tools through articles, blogs, case studies, white papers, and we are going to be sharing that information. We recommend that you go check it out, digitalmanufacturingreport.com. So let me leave you with 3 words: opportunity, potential, commitment. I hope you've seen 300,000 small, medium-sized manufacturers in the U.S., 2 million globally. That's an opportunity. It's a blue ocean opportunity. There's a potential here if we can figure out how to reach these companies, how to bridge the gap, how to leverage the collaborative model, how to come together within the predictive innovation centers to develop the tools, the technologies, leverage the investment, the infrastructure, the talent, to bring these tools to the missing middle. Now, the commitment that is required is significant. And by that I mean, this isn't going to happen next year. This is not a 1 or a 2-year plan. This is really a 20-year commitment to right this ship. Big ship, small rudder. We got to start turning, and we got to keep turning until we get the missing middle back on path. I want to thank you for your time today.
I want to thank you for your attention. You know, we ended the conversation just a moment ago talking about the opportunity and the potential, the commitment required, and I want to share with you some opportunities on how to take advantage of that if you're interested. And at NCMS, we've started something called the Digital Manufacturing Strategic Interest Group, SIG for short. And right now we have about 20 organizations, vendors, universities, large, small manufacturers, all interested in one thing, and that's bringing smart manufacturing tools to the missing middle. If you're interested in those, if you're interested in helping with the talent, investment, infrastructure, we'd love to have you as part of the team. My information is right here, Jon Riley at NCMS, and you can either email me or contact us at the website. We'd love to engage, love to talk to you, and partner with you in making this a reality. Thanks.